welcome everyone. Let's see if we can get. Hello, my name is Ted Singh. I'm the software development manager at Cascadia Scientific. We're a data science and software company in the mining industry based out of Vancouver, British Columbia, Canada. I'm the crusty old guy here, computer engineering by training. My specialties include robotics, industrial IoT, and embedded systems. So when I joined, it was kind of a perfect fit for when I came to Cascadia. As an old fogey, I've done many things from software development to software management, building products, becoming a product owner, a program manager. I've held roles in business development. But for the last 20 years, my specialty is helping build software teams in a startup environment. It's very fulfilling to bring new products to market. And when I'm not in Cascadia, I'll be on a golf course or walking my dog. Today, I wanted to talk to you about getting from sensors to usable data, a software journey. That sounds a bit boring, so let's start shake things up a little bit and let's choose a better title for this talk. How's this? How to make tasty soup of data and software. For those that don't know, this is Mark Wiens. He's a famous YouTuber who travels across the world and tastes authentic street food. He goes from India to Thailand to Africa, but when he finds something he really likes, he usually does that traditional wow, like he's doing here. It's become a meme. So to start this presentation, I wanted to talk to you about a couple of wow moments that I've experienced. And what this has to do with mining, just bear with me. Just give me a few minutes. One of the wow moments that I can clearly recall came when I was in Las Vegas for a conference a few years back, pre-COVID, when we could actually go to conferences and meet people. Anyways, that night we hosted customers at a local Brazilian restaurant. It was a great location, great company, the food was awesome, but what made it special that night, chefs were celebrating winning a national contest where they were lucky to, they had won a recipe for soup, and they prepared that winning soup for the restaurant that night. It was honestly the best soup I've ever had. I can still remember it to this day. Upon reflection, so many things had to happen for me to have that kind of experience. We had to walk into the restaurant at the right time, after the chefs had created the award-winning recipe and the chefs had brought together local and seasonal ingredients together. After it had been prepared and served properly, again, a lot of things came together for just that one tasty soup moment, a real confluence of factors. So, sounds corny, but there's another wow moment going on in mining, and it has to do with data science and software. The combination of several factors, technology factors, are bringing together a real opportunity. Ingredients like the ubiquity of sensor data, computing environments, industrial IoT, software libraries, visualization tools, data, lots and tons of data. So bear with me, sit back, and I'd like to take you through my data and software kitchen. So the premise of this presentation is to tell you that over the last 5 to 10 years, there's been a confluence of factors, largely technological, that are enabling a new window into mining operations and efficiency. If I could represent it as a stack of ingredients, and then on the left-hand side, I've actually made icons of this stack, and follow along as I talk through this stack. So first of all, just like your Fitbit and Apple Watch, it all starts with sensors. More and more sensors are being deployed on physical assets all the time. Our hardware platform connects to an ever-growing list of these sensors, from fuel measurement to location measurement to motion and altimeter sensing. And of course, probably most importantly, we also listen to the vehicle network, J1939 and older variants, which are constantly streaming data for major components, engine components, for example. There are advanced sensors for checking oil condition and tire pressure. As Tesla has shown us, sensor information can revolutionize how we see the world. The data and software changes that we are seeing start right here. So secondly, thanks to Moore's law, which has governed the power, speed, and efficiency of computing, basically doubling the performance of computers every 18 months, even to a guy like me, that's astounding. It's amazing. What it practically means is that our hardware platform can pre-process a lot of the sensor data in microsecond intervals. For examples, let me highlight some of this capability. We can do precise real-time fuel and emissions collection. We can monitor payloads and states as they happen. We can watch for key equipment events, alarms, and DTCs as they stream in. Okay, we've got the sensor data, but now we need to get it to a place where we can aggregate it and throw some serious compute resources at it. We need a pipe to get it there, and that's where telemetry comes in. That pipe is typically cellular. Thanks to ongoing improvements in the cellular infrastructure, we've seen most sites support 3G, 4G, LTE, and I presume 5G when it becomes available. We also have other options like Wi-Fi and Ethernet. Some mines have also have their own private RF land mobile radio network, for example, Tetra-based systems. This pipe also needs a communication protocol to transmit securely, effectively. And here we use protocols like HTTPS or MQTT. Oops, bear with me. We also need different strategies for different types of data systems. There are periodic snapshots for slower changing data, and then there are events for real-time systems. We need the smarts to be able to handle adverse conditions like the temporary loss of communication pipe. That's where we'll need to store messages until we regain coverage. At the other end of the pipe is an ingestion engine. It serves an important role in keeping our data secure, ensuring authentication and data validation. As part of that ingestion, I should also mention that we don't just take from vehicles. We get data from things like weather APIs and customers' operator shift data. The ingestion engine is just one piece of a much larger set of servers in the cloud needed to support a complete system. It should be noted that in the past, this was done with on-premise systems that needed a team of IT specialists at each mine location, managing updates, system administration, networking. This is kind of stuff that Ben was talking to about it in the previous presentation. This has changed, though. The cloud allows us to greatly improve how we deploy a full compute infrastructure. No more shipping of physical servers to a location, finding rack space, modifying the network cables, installing software, managing updates. We can now create compute resources virtually. In fact, I can do this using a script, and 5 minutes later, I can have a running subsystem. We are running hundreds of microservices and batching operations on a multitude of servers, each connected to each other via a private network. Most of our critical services are housed in containers like a Docker container, virtualized building blocks per se, like Lego. So when the demand is high from our users, without human intervention, we can automatically scale to add more of those Lego blocks to give our users a good experience. And when we sense that, and we automatically sense that demand has waned, our system can automatically go back to the normal size, the elastic portion of what Ben was talking about earlier. There are many cloud providers which offer a broad range of these services. We are primarily an AWS Amazon house. Okay, so we've collected the data on our awesome compute platform, but we need to make it usable. Our cloud uses specialized servers to host the data. It needs to hold terabytes. We're not quite at petabytes in our company or industry, but that's not crazy talk. The raw data that we've collected from the field isn't perfect. A great deal of our effort in our company is devoted to cleaning this data. Fortunately, over time and through sort of like our data science team, we've automated this with bots or daemons. That's a software term for little things that run in the background, which I've poorly illustrated here using those gears. But these things clean up the data for us. Finally, to prepare the data for upstream use, we need to curate it. That is, place it in proper piles. We can use the data to, for example, we can use this data to figure out dump and load cycles. So when this information is required as part of a report, it's ready for use. Same with things like hourly or shift analysis. Events, because of their temporal nature, also need to be treated different. Now that we've got good data, we need to stop and talk a little bit about data security. You can't skip this part. This is fundamental. First, all incoming data needs to be secure, authenticated, and validated. We use secure protocols as I mentioned before. All outgoing data must be authenticated as well, and authorized users need to be allowed via secure methods. Many customers have existing security infrastructures, so we integrate with things like single sign-on or Microsoft tools like Active Directory. And we are constantly monitoring this data, how it's operating, logging and alerting our team internally of any issues. All of this has to be governed by a measure of practice. For example, at Cascadia, we follow the NIST cybersecurity framework. As a software manager, I have to say we live in a lucky time because there are so many libraries and frameworks for reporting, charting, and visualization. I couldn't even imagine doing this stuff, but the stuff that my team does is ridiculous compared to what was available in my age. With these tools in hand, let's start with the basics, which are reports that analyze how things are running and meeting benchmarks. Once you have your data curated properly and tools in hand, reports can be generated fairly seamlessly. In fact, we offer a wide range of standard canned reports and charts out of the box. Software systems also need to be able to handle events and alarm information. For example, you may want to be notified of a critical maintenance or related event because, let's say, an oil sensor or diagnostic trouble code or road imperfection comes up. Our point of interest workflow allows us to see specific locations where events occurred that need further attention. For example, improper road conditions that might affect vehicle health. Mapping systems have come a long way. And with drone footage and GPS, we can provide advanced visualization of paths and heat maps. Of course, there are a ton of other usage for our data. You may be interested in emissions for regulatory compliance, or maybe product comparisons like comparing a type of fuel or vehicle accessories. And you may want to use this reports for training operators based on their performance information. Okay, so we're finally at the data science part of the talk. 16 slides in and I'm officially on theme. This used to be the realm of what I call application engineers, but times have changed, and armed with software tools and libraries like I've shown here, these engineers or mathematicians or statisticians now have some serious superpowers. They can take the data and make it into insights. I won't do this true justice, but I suggest you come to tomorrow's lectures by either Dave Reed or Nick Dembeck, and they'll do a deeper dive into this topic. I'm only going to do a quick overview here. With stats and models, we can go beyond just a retrospective look. I mean, looking just in the past. We can try to understand what affects performance, conjure what ifs, and make decisions based on data. We can use the past data to kind of potentially predict future operations or benchmarks. And with enough data, we can start enabling machine learning where computers can try to identify insights that might not be caught by humans. For example, I just give a quick example of what we do for our machine learning workflow. We look at dump and load cycles, build models with linear or gradient boosted trees for different metrics to determine efficiencies of equipment or operators. Finally, just because we have data and can do reports and data science problems doesn't mean we're done. With any enterprise, there are many other systems that we need to be able to interface to, whether it be an accounting system, an external reporting system, production management system, thank you, FMS system, maintenance system. There's always a need to exchange data. We've developed APIs using the Open API standard for allowing customers to pull data from secure, curated routes. So you can use it to get topical information on other software or to take it to your Excel spreadsheet. We have developed systems to allow customers to share their data with us so that we can get more context for our data analysis. Finally, real-time systems may need other pathways so that we can give you notifications that are of immediate concern. So that's a very quick journey. I hope that I was able to shed some insight. I know that each one of these slides could be a separate presentation onto themselves. But to summarize, there's a transformational change going on, brought together by several technological environments or advancements. It's being rolled out to businesses worldwide, including mining operations. I encourage you to investigate this change and how you can benefit from it. So hopefully, coming back to my earlier part of the presentation, I hope I've given you a pathway for making your own tasty data and software soup. And before I open it up for questions, I have a surprise for you. Remember the soup story? The restaurant made the recipe available and gave it to all guests. And I'm happy to share with you when we publish this presentation. While I can't physically give you the soup, I'll try to answer any questions you might have.
Thanks, Ted. So I got a few questions here for you. The
Sure.
first one is from James. What data do you make available via API? We use Power BI. Would we be able to access that data?
Yes, actually, first of all, one thing I should say about our API, it's a living piece of software, so it's constantly growing. So I think that we made it available just earlier on in the year for our customers. And initially, we've provided information on equipment, information on operators, information on heat map data, but we're constantly evolving and adapting our API.
So in that light, what data can be shared with maintenance teams and what benefit does it have for them?
Well, certainly equipment information is of use to the maintenance team. And one of the things that we're rolling out right now is information on events, like things that might be adversely affecting equipment, like things like racking events where there's some torsion stresses applied on the vehicle, things like strut measurement, things like potholes or road imperfections. That's going to be available through our event API that people can take directly.
That's great.
Like I said,
Robert
Ted,
asks,
mention DTC, Ted, because I think for the maintenance team, access to DTCs, either standard diagnostic trouble codes or OEM specific ones also would have some pretty big significance.
Yeah, so yes, if you didn't hear Kevin, there is diagnostic trouble codes also available from vehicles that we are bringing into our software that's going to be available through the APIs as well.
all right. Can we add any sensors, custom sensors? How is this done?
Yes, absolutely. We have first of all, I think that when we engage with our customers, we typically, look at what their requirements will be, and we certainly have room and availability in our ports to accept different sensors, and we'll have a consultative approach with our prospects to figure out what they need to measure. We have some standard sensors, obviously, but then we can look at the supporting sensors that they may need to use as well.
Great. And how do you bring in operator shift information into the platform?
Yeah, we have what we've done is it's very much like an API, but what we've done is we've shared. This is actually a unique problem. Maybe I'll go into it a little bit deeper. So one of the things we wanted to do was integrate operator data so that we can tell our customers how operators were performing. And maybe a year or two back, customers would send us Excel spreadsheets. And, this is prone to error and it's a very manual process. So we worked with our customers to develop a method of automating this process so they can use their software to initiate a collection of data at the end of each shift, and then send that data to us through secure FTP to a location that we have made available to them. And at that location, when we sense a file being dropped, we will launch a batch function that will process this data automatically. So from the time, instead of using an Excel spreadsheet, a customer can share that data, and within 5 minutes, their operator data can be recognized within our system.
You mentioned the NIST cybersecurity framework. Are there other frameworks out there, and why have you selected NIST?
There are other frameworks out there. To be honest, I can't remember any of the top of my head, but there are standards out there, and I can make them available after this call. But we chose them because we were working with our customers who had adopted the same platform, and so we thought this would be a good way of sort of conforming to the same sort of standards that they were using.
And Ted, I'll just add to that. One of the nice things, we just heard from Ben Weber at AWS, and when you move to the cloud, a lot of the security framework requirements relate to physical security that can be very challenging for medium-sized enterprises to necessarily meet. Whereas, all the notions about physical security, the way you protect buildings, the way you manage climate control and water ingress, all of these things, being outside, being in the cloud can be very helpful, and we can focus on security really only at the digital level. So encryption, access control, policy around information access, and these kinds of things, which is very nice that we get to lean on or stand on the shoulders of Amazon in this case for things like physical security.
Great, thanks, Kevin. So one last question here. Do your sensors interfere with ordinary truck operation?
I would say that we're largely doing a listening operation. So we are very passive in that capacity. We're largely listening in and not affecting sort of vehicle behavior or vehicle operations. And that's a very, very important guiding light for us, is to ensure that, our customers' equipment remains operational, but we can still, at the same time, give them as much data as possible that's emanating from the truck.
And one thing I can add to Ted's comment is that a number of the equipment OEs, I don't want to name names on this in this setting, but a number of the equipment OEs and engine manufacturers are actually Cascadia Scientific customers. And so the answer is no. We do, our sensing nor our electronics, none of them would have any negative impact on availability.
That's great. Thanks, Kevin. If there's no other questions, I think we can move on to the next.